Entschuldigung Sie bitte, my Deutsch is eine Katastrophe. So from there, I will continue in English. I apologize for that. And my name is Lukas. I work for Red Hat in Brno, in Olomouc actually, which is an hour drive from Brno in Czechia. I work in Satellite 6 engineering, working on Foreman, the open source project. And today, I would like to talk about motivation, why we should be caring about provisioning commodity hardware, bare metal. I'll do a quick overview of what Foreman is. If you don't know Foreman, it is the open source project, the upstream for Orakino or Satellite 6, or I think there is another product based on Foreman. But you can still install Foreman your own and download it for free as in freedom. And then in the second section, I would like to talk about discovery. A little bit of state of discovery today. I'll talk about and explain what discovery is in a minute. And discovery new generation, something that we are thinking right now, how to rebuild it and improve. And then I have a short section about post-discovery. There is this idea I have. I would like to grab some feedback from you guys. So why we should care about commodity hardware, actually? Because there's the cloud, there's the infrastructure, IT infrastructure is so fast these days, right? So why is that? I think my theory is that virtualization is the root cause of this, because it's so easy to create a new infrastructure, to new VM. It's like one click away. And so developers and operations started to leverage that fact that they can create VMs so fast. Now there's cloud. Cloud's just everyone else computer, right? And it's usually a VM anyway. So why should we care about bare metal provisioning? And I say it's because sometimes the cloud is not the answer. You sometimes want to run your own data center, or you want to run your own OpenStack or OpenShift, and you need to obviously install those infrastructure things. So that's why you should care. That's why you can leverage Foreman, Orakino, Satellite, and other projects and products to actually do this work for you. And also special cases that in this post-meltdown era, you sometimes want to leverage your hardware, and squeeze all the power from it, right? So I hope that you think also as me that infrastructure as a traditional infrastructure environmental is still relevant. So by commodity hardware, I really mean the generic or vendor-specific x86 running on a standard networking and stuff like that. And there are Foreman offers basically two main workflows, provisioning workflows. The number one is network-based provisioning. Basically, if you can achieve setting up a DHCP and a PXE environment, and if you can, negotiate with your infra and network team to get Foreman integrated, then this is the most recommended workflow. It works easily. You configure your nodes to start from network basically, and then you let Foreman to manage the PXE configuration, DHCP configuration on its own. And you can easily, using a mouse or using a CLI command, schedule those servers to be either provisioned or to be booted into what's called discovery, or to be booted from the local drive, basically, to boot into the production mode. The second approach is something that we're talking about for a long time, and that is image-based provisioning. Because when you're installing your nodes using OS-Installer, it takes some time. The OS installer needs to boot up, initialize network, initialize storage devices, partition disks, download the packages, and install the stuff, and then run those post scriptlets, which usually do a lot of stuff, setting up your configuration management, perhaps. Image-based provisioning is the answer, because you can actually install bare metal nodes as simple as downloading an image and dumping it to your hard drive. Essentially, this is the same thing as what cloud does, basically. And there's a secret that Red Hat installer Anaconda, actually starting from version 7.4, actually supports image-based provisioning. I don't know why Anaconda team is hiding those new features, but some customers obviously wanted this, and it was it's been shipped. And I think it's not well documented by, if you give it correct parameters, you can install Red Hat from an image. And it goes hand in hand with this new feature called blueprints in RHEL 8. You can create those images very easily using Cockpit. It's a new feature. So that's a nice feature. But also there we are talking about maybe extending discovery to the point where you can discover your node and dump the image onto your discovered nodes as well. So that's also an option. So we have tools. Foreman has tools. And it's also, I like to say that Foreman is good in working with community hardware because our BMC integration is pretty simple. Foreman can actually integrate with IPMI tool, which is a Linux command that can do, if you give it a username, password, and IP, it would, allow you to boot up, start your server, turn it off, and reboot. So this is something that we would like to work on as well. So what is actually Foreman? If you have those Orakino sheets, it's pretty much nicely explains what Foreman is. So basically, it's a management for your servers in a simple term, and it has really nice capabilities around provisioning, content management, bootstrapping, and inventory. So I'll go one after another. Provisioning is the thing I want to focus on in this talk. Foreman can do bare metal provisioning, virtualization, and cloud. This means that once you set your Foreman, you can decide, and you can basically have a single point of truth for your infrastructure. And it doesn't matter if it's AWS or your OpenStack or bare metal servers. You have a unified user interface for all the users, operators, and developers, and you can do that. Bare metal, that's bare metal. Virtualization, we do support overt Rev, that is overt is upstream for Red Hat Enterprise Virtualization, and VMware. We also do support libware, but this is kind of a testing. It's not recommended for production, although a lot of community users use libware for production. And for cloud, we support all major providers, including OpenStack. Basically, the workflow is that you create a new node or new host in Foreman, and you select that it's the AWS, and then on the next screen you can actually select the image you want to boot and number of CPUs and stuff like that. Content management is another huge part of Foreman. It's being brought by a plugin which is called Catello, and it lets you synchronize and manage content. By content, I mean packages usually. It does support YAM repositories and Debian repositories, as well as other things and artifacts like images, Puppet modules, and stuff. What Foreman is good for, although Foreman has a very capable templating engine that lets you essentially generate various text-based templates or text or files and deploy them onto your either configuration directories or nodes themselves. No, Foreman was never meant to be a configuration management system. It is simple configuration management system to actually bootstrap your real configuration management system. So I'm talking about Foreman, getting up and running things like Ansible, Puppet, and other configuration management stuff. And last but not least, inventory. Foreman is very, very good, and historically it has been an inventory for Puppet for years, and then our community were adding more and more plugins and providers. It is single point of truth for your infrastructure if you go for Foreman. It gathers facts and reports and pillars, and every single configuration system has its own name for the same thing. It's essentially facts about your systems or about your nodes and hosts. And it gathers also reports and present them in a nice way, and also things from OpenSCAP security system. So when Red Hat hired the original author of Foreman, Ohad Levy, we started adding more and more enterprise-grade features, which are Typical Red Hat customer is a big customer, and they usually need things like multi-tenancy, role-based access system, integration with MSAD, IDM, REST API, and CLI, and localization. We do support all of these. So sometimes these features can be a little bit overwhelming for community users, specifically if you are running small business and you only have 3-4 operators. You probably don't want to have a multi-tenant application which lets you to create a multiple sub-organizations and locations and complex RC system that lets you create permissions and stuff like that. However, it is good to have it if you expand and stuff like that. So Foreman is really enterprise-grade application. You can, even the free version is, of course, there is nothing, no hidden software. If you buy Satellite, it's just Foreman in red color. There's nothing like, the crippleware. It's not crippleware. I sometimes refer to some software as crippleware, where you have a community version and some kind of a paid version, which has many more features. That's not like that. So technology-wise, Foreman is Ruby on Rails application. It's pretty easy, I'd say, to hire Ruby on Rails programmer, because Ruby on Rails is still a thing. It's like 5th, 6th top stack these days. And there's also a component called Smart Proxy, or sometimes referred as Foreman Proxy, which is also written in Ruby in Sinatra application. And it's a very small component, almost like a microservice, but it's not microservice. It's not running in a container, I guess. You deploy these in remote sites, in remote data centers, and there is only one connection each direction, HTTPS, from Foreman and from a Smart Proxy. So this is the communication channel that Foreman leverages to talk to Smart Proxy. And Smart Proxy on those remote sites can do DHCP management, TFTP files management, and things like that. So this is our architecture. It's a federation model, I would say, that allows you to, you always should aim to deploy a single instance of Foreman. Even if you're like a huge company, you should aim for single Foreman installation, and then many of these smart proxies around the globe, if that's possible, of course. And Foreman runs on Unix. Pretty much any Unix should do the job. Smart Proxy also runs on Windows. Foreman itself does not run on Windows, but Smart Proxy does. That's for Microsoft DHCP and TFTP and DNS integration. You can manage Windows, DNS, and DHCP from Foreman. That is possible. But we do provide packages for Foreman itself for CentOS and Debian. So if you want to try Foreman for free, you can go ahead. It's best to choose CentOS or Debian because they are packages which are well maintained. It runs on PostgreSQL. We are in process of today. You can install Foreman on MySQL as well, but we are currently in the process of getting rid of MySQL and migrating our users to PostgreSQL, which enables us to leverage and to stick with more fine-grained features of the SQL Server. So stay tuned for new features and performance improvements. We also have a Puppet-based installer. It has probably 450 parameters, so you can install Foreman very easily. So it's 10 years old open source project. We have a lot of contributors. We have a core team sponsored by several companies, and we are working 24 hours, around the globe. So if you come to our channel and if you want to test out and do a POC, a proof of concept environment, just go ahead, and we're there to help you. We have open core architecture, which means that you can download a lot of plugins and extend, because since Foreman provides you a nice single point of truth where you have your inventory of your infrastructure, it's good to have things like remote execution. So if you want to ad hoc command on your host to do some thing, you can install this plugin and do the stuff. As you can see, we have many of these plugins. This is from the community survey we do every January. So last year we measured our popularity. Catalog, hits the top. And remote execution discovery is the plugin I want to talk about today in more detail. So if you want to provision your nodes in Foreman, what you can actually do. So for bare metal, we have the PXE process, which is the most recommended if you can, again, afford to boot from network. Some environments, some customers don't like enabling PXE because it's essentially from security standpoint, it's a remote execution by design. However, if you can afford that, it's a nice workflow. You can boot your servers from network and, you know, very flexible. iPXE is just an extension of that if you want actually to avoid TFTP protocol, which is UDP based and not very reliable over VPNs and stuff, then you can of course do iPXE as well. The typical workflow is you create your host using command line client, API, or user interface. It's a web user interface, of course. I think it's pretty obvious that it's a web app. You fill in all the details, you fill in the MAC address of your provisioning interface, and then click Save, set all the parameters, which operating system, which image, stuff like that, and then you boot up your host. It will boot from network, recognize the configuration, and boots up, starts OS installer. OS installer, you know, checks and downloads the installation recipe, which is basically a text-based recipe that tells you how to do partitioning and stuff. So in Red Hat terms, this is kickstart. In Debian terms, this is preseed script. And then from there, it reboots into the operating system. You can extend this workflow by installing what's called discovery. In that case, when you turn off on your servers, which Foreman does not know, they will boot up into a live CD called Discovery Image. It's 300 megabytes live CD based on CentOS. And the only purpose of that image is to boot up and register to Foreman using HTTPS. Like here I am, and it uses a Puppet factor to report those facts. So like I have 16 CPUs, 2 terabytes of memory, and you know we had a node that had 2,000 of disks, so there was a bug, and it was a little bit too big JSON. So and it reports all of that, and then you can from there you can either pick those hosts manually using command line client, API, or web user interface, or you can even do automation rule that would automatically start provisioning those hosts. Bootdisk is another nice plugin. If you can't afford PXE or Discovery, you can actually download a pre-built small boot disk, which is based on iPXE, which is just 1 megabyte, and you can put this onto your USB stick and stick this to your server and then turn it on, and it will automatically match the server with your inventory and start downloading the installer from there without PXE, without TFTP, even without the HCP. If you don't run the HCP, you can do actually static boot disk with the IP address allocated in the USB stick. Today I would like to talk about recipe disk, which is a new feature kind of it's a script. I'll talk about this later on. And for virtualization, you can do everything I've just described, and plus image-based provisioning is also a thing. If you have a template in VMware image, you can just pick this from Foreman and just click install, and it would do the job for you. In cloud, of course, although some clouds do support PXE, I think Azure, we just support image-based provisioning there. So that's something we do. Yeah, this is Word Premiere. I have created this small script called Foreman Recipe Maker because in Anaconda, starting from Red Hat 7.2, there is a hidden feature again that if you put an USB stick with a special label and install an installation recipe called ks.cfg, that's the kickstart, Anaconda from Red Hat, so Fedora, Red Hat, CentOS, Oracle, Enterprise Linux, and stuff like that, it will automatically pick this up and install the system. Previously, it was not there. Now the feature is there. So this is kind of a similar workflow as boot disk. This recipe maker is just a small script that reaches out to Foreman, downloads downloads the Kickstart file, and puts it into a USB basically image, which is fairly small, just 100 kilobytes. So this is new workflow you can use from today, I guess. And script is very small. And if you there's one drawback though. this only works with Red Hat. I've done my research, I did my homework, and Debian installer does not seem to actually automatically, or even if you, it doesn't automatically search on a removable drive for preseed. What you can do is you can remaster Debian installer's CD or PXE image and add a parameter. So and you say that from USB and this file you want to actually use the preseed. So if you want to do that, go ahead and extend that script. So Foreman Discovery, as I said, is a simple extension to the PXE workflow. The only basically thing it does is register your host, your nodes into Foreman and wait for orders. And the order, there's only one order, and that is a reboot. Just Foreman says this and that server just reboot because everything is ready for provisioning. So this has some limitations actually. So this is my second part of the talk, where I would like to talk about the future of discovery. There's a long thread in our community site, discourse, community.deforeman.org, called Improving Discovery Workflow, and I'm basically describing what the limitations are, and I'm starting discussion about that. So first, you can actually change the network configuration. If you have your host discovered with four network cards, and one of the network cards is considered to be provisioning, that's the configuration the host will be configured. You can, of course, jump in and change the configuration with the Foreman user interface, but again, it's a manual intervention. You want to avoid that. You want to automate, right? So this has not been really possible. Also, we have confusing workflow which is called PXE-less. You can actually boot the USB discovery from a USB stick again, and if it detects that it has been booted from a removable drive, it will present you an interactive text user interface where you can add your network credentials and then from there do the discovery. And instead rebooting, the host uses kexec technology to replace kernel and start the installer. We found that the kexec is a little bit unreliable, so we would like to offer some kind of a replacement workflow for those users who like this, but it doesn't work for them. And this is the major point. The third one is not extensible. Discovery image is it's basically a live CD. If you ever created a Fedora live CD, there's a live CD creator. You need to go through the process. It's lengthy, and it's challenging for some. And people are asking us, like, can we maybe upgrade firmware on all these discovered nodes? We would like to, or maybe do a CPU burn to, identify which hardware has a failures. And you can't actually do this without rebuilding the image from scratch, which is a lengthy process. So here's my proposal. We would like to change the discovery image a little bit, and the initial bootstrap would be the same, boots up, HTTP request to Foreman. We would like to extend this and do at least certificate check, fingerprint check, because PXE is remote execution by design, so it's not like we're able to secure PXE, but essentially it adds some obscurity to attackers to at least do a lot more work to attack. And then we would like to leverage a plugin which is called, very popular plugin, Remote Execution, which is essentially SSH in a loop for your servers. Just from you have a convenient user interface or CLI or API for that. And we would like to be able to allow our users to run SSH templates. Of course, as anything else in Foreman, this leverages the templating engine. So you have your context of your host, and you have all the information and parameters you can use and generate those SSH templates, basically shell scripts, and run them on your hosts, which is great. So you can now upgrade firmware, install packages from repos and stuff like that before the host is even provisioning. So that's a cool idea. And also, by leveraging the templating engine, this means that you could actually do something with the host configuration itself, either when it's actually discovered or when it's being started, the provisioning process is being started. So in that case, you could write the templating engine utilizes a function or language called ERB, embedded Ruby script. If you know Ruby on Rails, this is basically something like PHP, basically. And you can leverage this to actually change the configuration. So this actually if this idea is correct, and so far the feedback was good. This could be maybe starting next year, new version of Discovery that's much more flexible, extendable, leveraging templating engine, which is really powerful feature of Foreman provisioning. And this could eventually lead to better workflow with Discovery. Also, I set some secondary goals. We would like to upgrade Factor, upgrade to CentOS 8, which has been released recently, and do some small changes here and there. So hopefully the next year we will see much more capable Discovery. Please, if you use Foreman for your deployments, for your provisioning, or for your management, configuration management, and changes management, and content management and syncing, share with us your templates, because Foreman comes with a lot of templates, and it's really powerful to have them. So we have templates for Autoyost, Kickstart, Debian, Ubuntu, Arch Linux, and BSDs, stuff like that. And the templates has many parameters, so you can easily parameterize this. You want to set maybe time zone, you want to set language, everything works, nicely. But this is not possible without help from the community. So every time you have some template change, go ahead. Of course, you can clone these templates and on your installation do the changes. That's why templating was introduced in the first place. But if you search to share your work, then in the next version of Foreman, you will have those changes in the main line. Now, I would like to talk about Discovery. And I'm going to now switch over to the third part of my talk, and that is the post-Foreman Discovery era. I always try to think about how to improve workflows. I talk to people on conferences, and I'm trying to find what to do to create a better environment so customers can actually and users can actually provision their servers and nodes more easily. So I was thinking how to actually improve that process, because PXE is very nice workflow and Discovery is very nice workflow, but it's a little bit sometimes complicated to set up. Sometimes it's complicated to understand, or PXE is sometimes really complicated. What if, and I have this idea, and maybe it's a dream, that what if there is a way to actually make OS installer, which is, let me just get two examples, Anaconda from Red Hat or Debian OS installer. These are the typical two OS installers we use. What if we could make them to actually register those systems just like as Discovery? Register to your inventory, whatever this is, either Foreman or something like that, or build maybe your script. You can write a PHP script that can be inventory for your servers. It's completely fine. If that does the job, that's great. And what if these installers could basically wait until operators choose either automatically or semi-automatically to install those systems? This is kind of a dream I have. So I started writing this proposal or specification, which I would like to reveal sometimes next week or two. And the idea is really simple. I don't have a name for this, but working title is OS Installation Wait Protocol. And the idea is simple. Like OS installer, when it reaches out to HTTP server to get the installation recipe, which is usually Kickstart for Red Hat, Preseed for Debian, it can send some information along because it's a HTTP request, and HTTP requests do have headers. So what if there is some basic facts about the system reported as headers? Maybe MAC address, that is very important, number of CPUs and memory. Serial number of vendor would be nice. It's easy to find out in Linux, just one file. And optionally, total storage space. This one is a little bit tricky because at this point, the OS hasn't been initialized fully yet, and this might not be yet available. So total storage space is kind of question mark if that's possible or not. I haven't implemented this yet. and we can, and the installer could send this as headers. And in fact, Anaconda does this already today. I think starting from version 5, RHEL 5's Anaconda sends MAC address or MAC addresses already in the HTTP header, and starting from 7.3, I think, it also sends a serial number of your server in the HTTP headers. So the change would be pretty small there. And then it's obvious. What if the installer would wait until the response is HTTP 200 OK? What if Foreman or any kind of provisioning system responded with 404 or 408? Doesn't matter really. And this would be interpreted as, just wait for 1 more minute until I get to you. So this is why I named this a wait protocol or wait list. It should be pretty easy to understand. I've talked to Anaconda engineers, and they said me, like, if that's opt-in, that's something that we could probably accept. So I need to do my homework and talk to Debian installer developers as well. In both cases, they're using wget or curl. I think it's BusyBox version, which is fairly limited. You can detect 404 and 200 with that. I'm not sure. So I need to do more of research. But this could be a nice workflow, because if that's implemented in both installers, then you could leverage OS installer to basically wait until the node needs to be provisioned. So as I said, these should be small patches, small changes. Opt-in, so we don't want to break existing installations at all. We don't want to have servers indefinitely looping and waiting for something that doesn't happen and that won't happen. So opt-in via kernel command line option, which is great. If you use PXE, that's just a parameter you need to set in your PXE configuration, and then that's it. So this could be actually something that could distill to a nice idea. So I would like to hear from you more feedback, more feedback about Foreman, more feedback about discovery, more feedback about provisioning and questions, of course. I'll do my best to answer those, about Foreman provisioning and about this idea of waiting list. And with all that said, I think it's Dankeschön, and time for questions.